All right. So today we're going to cover section 7.4. And factoring polynomials. And basically, we're solving polynomial equations. We haven't been solving equations. You know, we've been factoring, we've been using synthetic division, we've been using long division, and it's all for one reason. And why do we factor? To find the zeros, right? That's why we factor, to find the zeros. That's why we use quadratic formula. That's why we use synthetic division, why we use long division. We're doing all this stuff to find the zeros. So let's take a polynomial. 28x minus 5x squared minus 3x cubed equals 0. And let's find the zeros. And the first block of problems that we're going to be doing has to do with factoring. So we're going to factor that. If you want to factor, you want to reorder all of these in descending order. Put it in standard form. So negative 3x cubed minus 5x squared plus 28x. All right. First thing you want to look for, does this have anything in common? Does this polynomial have anything in common? What is it? X. And let's do it better. Let's do one better. Let's take out a negative x so that my leading term in the parenthesis here is going to be positive because it'll be easier for us to factor. So this becomes 3x squared plus 5x minus 28. All right? And then we're going to look to factor what's left here in parentheses. So we have negative x times, and we'll do our guess and check. Do we have a choice really for 3x squared? It's going to have to be 3x and x. It can't be anything else. And what about for 28? Well, it could be 1 and 28, 28 and 1. It could be 2 and 14, 14 and 2. What else? 7 and 4, 4 and 7. I'm guessing it's going to be 7 and 4 because of this middle term being a 5. It's a lower number. And those two numbers are 7 and 4 are close together. And I think we'll find out that it's this way. If you check the outside-inside terms, I have a 12x and a 7x. And that'll give me 5. Okay. And we've done enough factoring to where I think it's going to go fairly quick for you. So I have 3 x's here. So either negative x has to equal 0, or 3x minus 7 has to equal 0, or x plus 4. One of those, if one of those are equal to 0, then the whole polynomial will equal 0. All right? So in the first case, x could equal 0. In the second case, x could equal 7/3, adding 7 divided by 3. And x could equal negative 4. All right? Describe the general shape of the original polynomial up here. What is the general shape? It's an S-shaped curve. Tell me about the end behaviors. Rises on the left, falls on the right. Okay, and we did that in section 2. All right. The zeros are 0, negative 4, and 7/3. Those are your zeros. Well, I can sketch it. I know it's going to rise on the left. Here's my zeros, and it's an S-shaped curve, and it'll fall on the right. And that's a pretty good representation of what that's going to look like, because I found the 3 zeros. Okay? I don't know how far down this will come here, or how far up this vertex will be, but I can just sketch it by knowing the zeros and knowing the general shape and the end behaviors. Let's take another example here of, let's say x cubed is equal to, oh, I don't know, 121x. Solve for x. Anybody want to divide both sides by x?
Yeah.
Could we do that? Actually, you don't want to do that because you don't know what x is. And if x is 0, then we divide it by 0. So we never want to divide by a variable. Okay? So what we want to do is we want to set this equation equal to 0 by subtracting 121x from each side. Then factor out an x. And does this second parenthesis, does this parenthesis factor? Does it?
Yes.
Into what?
X plus 11, x plus 11.
X plus 11, x minus 11, right. All right. All of the problems that you'll have will be able to be factored this way. Okay? And this is how you do problems. This is how we do problems 11 through 26. Okay? Next topic. The directions on the next set of problems say, use a graph, synthetic division, and factoring to find all the roots. Is there a difference between finding the roots and finding the zeros? No. No. Okay. All right, so let's take an example. Let's take x cubed plus, well, in fact, I put this into my calculator. We have x cubed minus 7x squared plus 15x minus 9. Okay, the directions say use graphing. So you go to your calculator and you graph it. All right, so I just put that in my calculator and I graphed it. Okay. Then use synthetic division. Look at the graph. Can you tell me what a 0 might be? Mark, what is a 0? 1. All right, so we looked at, we see it crosses the x-axis at 1. That's a 0. So let's use synthetic division. And I'll put the 1. And I have 1, negative 7, 15, and negative 9. Bring down the first number. 1 times 1 is 1. Add coming down. 1 times negative 6. Add coming down. And 1 times 9 is 9. All right. And 1 was a 0. Then we want to factor. Well, first of all, this is going to be 1x squared minus 6x plus 9. And I want to factor that. Okay? And it factors into x minus 3 and x minus 3. So what are the other two zeros? Because we know there's going to be 3 because it's an x cubed. 3 is a 0. 3 is a 0. And then, looking at the graph, we saw that 1 was also a 0. Okay? And because two of these zeros are the same, what that means is it's just going to touch at 3 and go right back up. It becomes a vertex because there's two of them. And then this should have been, and this will cross here at 1. All right? Now what if somebody looked at this equation and said, well, it looks like 3 is a 0. So we graph this. And it looks like 3 is a 0, so I'm going to put 3 up here. I should get the same answer, because 3 is a 0. So we'll use synthetic division. Whoops. Bring down the 1. -4, -12, 3, and 9. Now I have x squared minus 4x plus 3. And we'll factor that. X minus 3, x minus 1. So the zeros are from here that we saw in the graph, and then this one, and this one. So no matter what zero you use, we're all going to come up with the same answer. Does that make sense, Andrew? Okay? 3, 3, and 1 are your zeros. All right, now, when you graph on your calculator, you may be able to see all 3 zeros. And it may be real clear to you on your graph. But I want you to use this method here of graphing, synthetic division, and factoring. Okay? Make sure you guys do that, because that's going to come into play tomorrow. All right? Scott? No, I'm sorry, Kurt.
Just a quick question, I forgot for a second. How do you tell how many, basically how many x's the equation is going to have, like what kind of polynomial it is?
Yes.
Synthetic
You're going to tell by the degree. So if we have degree 3, there's 3 zeros.
Okay.
If it's degree 4, it's going to be 4 zeros.
All right.
Okay? This is how you do problems 27 through 38. That's how you do problems 27 through 38. Next topic. And final one. X to the 4th minus 8x squared plus 12 equals 0. Kirk, how many zeros am I going to have? 4 zeros, right? 4 zeros. I'm going to show you 2 ways how to solve that problem. What the book does and what I see. So I'll show you 2 ways. The book says, let me read the directions to you. It's on page 453. Use variable substitution and factoring to find all the roots of each equation. Roots are the same as zeros. They're saying I'm going to let u equal x squared. Okay, this is using variable substitution. Some students really like this. So then the middle term here becomes 8u, because u is equal to x squared. The first term then becomes u squared, and then plus 12. And you see why we did that, because now it looks like a quadratic function. And I can factor it into u minus 6, u minus 2. All right, so what are the zeros? U would equal 6, and u would equal 2. All right, I've solved for u. Now what is u? X squared. X squared equals 6. X squared equals 2. And what does x equal? No, not 36, we're taking the square root of each side.
Oh,
So x equals
okay.
plus or minus square root of 6, and x is equal to plus or minus the square root of 2. These are the 4 places where this function crosses the x-axis. Those are the roots. Those are the zeros. You can't see those by graphing those. You won't be able to tell. That's one way to do this problem. That's what the book suggests. And that's a very strong method to use. And we'll be using it throughout the course. Another way, x to the 4th minus 8x squared. I'm just rewriting that problem. I'm saying that if I look at that problem, it almost looks quadratic. Instead of the exponents being 2 and 1, they're 4 and 2. It looks like I can factor it just the way it is. It looks like I can put 2 parentheses and guess and check to where this is x squared and x squared. That's x to the 4th. And then 6 and 2. And so x squared could equal 6, or x squared could equal 2. And then from there you can go ahead and get your answers. So there's 2 ways that you can do those problems. Pick the one that you like the best. Okay? And this is how we do problems 39 through 50. Okay? Now, the problems on the bottom of the page, 51 through 60. I didn't assign those, and basically it's because they just wanted you to graph those in your calculator and trace to find the zeros. And I really didn't see the point in doing that. All right? Because we want to get as many exact answers as we can. It's got you rounding answers to the nearest 100th, I think, or 10th, or whatever it is, so I'm not really interested in that. So your homework on pages 453, 454, 12 through 50, the even ones, and 63 to 64, all of them. Okay? And that's your lesson.